Well, hello everybody. What I'd like to do with you today is this. There's nothing new on this worksheet that you haven't seen before. But what I've done in this video is I've reviewed everything that we've done in Chapter 5. I reviewed inflection points, I reviewed increasing and decreasing, I've reviewed it all for you. So if you'd like to grab your class notes and just follow along with me or fast forward to any parts that you might want to see. But here goes. What I'd like to do with you first, and you can pause the video and write this information down. But what I started class with is I went over how to do each part that we've done, meaning this. What I started with is this, and I hand wrote these while they wrote them down. I just typed them so that it would be a little bit faster. So if I scroll off this screen too fast, go ahead and backtrack, hit pause, and you can write this down. But if you're asked to find the intervals where a function is increasing or decreasing, here are your steps. You will find the first derivative. You will set that first derivative equal to 0 to get your critical numbers. And then we play the number line game. If it's positive, it's increasing. If it's negative, it's decreasing. If you're asked to find the extrema, we have two ways to do that. Way number one is if we've already done this part, just look at your number line and look for a sign change. Remember guys, if you're going to go from positive to negative, you just made a maximum. And if you're going to go from negative to positive, you just made a minimum. Now, we had another way also called the second derivative test. And remember, the second derivative test went like this. What you do is you find your first derivative and then set it equal to 0 to get your critical numbers. And then you find your second derivative. After you find your second derivative, you'll plug your critical numbers into that second derivative. If you get a positive value, you have a relative minimum. If you get a negative value, you got a relative maximum. So that's the second derivative test. If you're asked to find intervals of concavity, these are your steps. You will find your second derivative, and you will set that second derivative equal to 0 to get your possible inflection points. After you have your possible inflection points, you play the number line game with your second derivative. So that's how you get intervals of concavity. You'll see these in action here pretty quick. If you're asked to find inflection points, you look at your number line and you look for a sign change. No sign change, no inflection point. Now be careful. It's possible that you could have a sign change, but it not be an inflection point because there's an asymptote in the original graph. We'll do one of those to make sure you understand that. And then other little things that you need to look for, especially when we're graphing. Look for any horizontal or vertical asymptotes. You guys overall are very, very good at spotting vertical asymptotes. We could look at this function and know that we have a vertical asymptote at x equal 2. But there's also a horizontal asymptote at 5 over 1. We looked at those coefficients, so 5 over 1. We've done this a few times as we played increasing and decreasing. You look at your end behavior. For instance, if I have a 4th degree polynomial, I know that both branches are going up. So if you think about it, as we work left to right, I know this far left side is decreasing. I know this far right side is increasing. We would have to play the number line game with the middle to understand what's going on. And then if we're graphing and we're unsure, we can always plot a point to kind of see where we go. So pause that if you need to write that down, guys. Otherwise, I'm going to just keep on going on. Now, here's our first example. Find any relative maximums or minimums using the second derivative test. So in this case, using the second derivative test. So if you peek back at your steps, step number 1 will be find your first derivative. So I'm going to get 6x squared minus 6x minus 36. We're going to do whatever it takes to set that equal to 0. So I'm going to set it equal to 0, and I'm going to divide everything through by 6 and get x squared minus x minus 6. I'm going to go ahead and factor this into x minus 3 and x plus 2. So I have my critical numbers to be 3 and negative 2. Now, since we're using the second derivative test, we now find the second derivative. And to be truthful, you could use either one. I'm going to go ahead and use from the first derivative. That derivative is 12x minus 6. I need to look at f double prime of 3 and f double prime of negative 2. Now guys, remember, I only care if they're positive or negative. I do not care about the number. To be truthful, I'd rather you not put the number, because I'm afraid you're going to think that's a y value of the critical number. Well, if I plug in 3, it's positive, which means I have a relative minimum at 3 something. When I plug in negative 2, I'm definitely going to get something negative. So I have a relative maximum at negative 2 something. Now, I went ahead and ran these through for the sake of the video. When I ran 3 back through the original, remember whenever you need a y value, back to the original, I got negative 67 and I got 58 for 2. So there's my first example by the second derivative test. The second question just here says, state any relative maximums or minimums for x cubed minus 3x squared. Well, it does not say by the second derivative test, so you pick the way you would like to do it. I'm going to do it both ways so you can see them. Method number 1, the first method you learn. Let's find the first derivative, 3x squared minus 6x. Let's factor out a 3x, which leaves a x minus 2. And we're going to set that equal to 0. So I'm going to get critical numbers to be 0 and 2. So one way, go ahead and play the number line game with these. So if I plug in a 3 back in here, that looks like it's going to be positive, negative, positive. Now, looking at it, since I'm going to go positive to negative, I'm going to have a relative maximum at 0 something, and I'm going to have a relative minimum at 2 something. Plug those back into the original, looks like I would get 0 and negative 4. While I'm here, if you'd rather, I could have also found the second derivative, which is 6x minus 6. I don't know why I wrote it that way. Second derivative is 6x minus 6. I now need to find f double prime of 0 and f double prime of 2. When I plug in 0, I get a negative number. Tells me there's a relative max at 0, and in this case we know it's 0. And when I plug in 2, I got a positive number, which tells me there's a relative minimum at 2, and since we did that over here, I know it's negative 4. So guys, 2 ways to find that. And I just did them both. You didn't have to do them both. I just did them both. Here goes my number 3. Find any intervals of concavity. Well, guys, remember your steps for concavity. Find your second derivative, set it equal to 0. So I'm going to find my first derivative, and I'm going to get 4x cubed plus 3x squared minus 6x. Now, we were not asked to find increasing or decreasing. We were not asked to find extrema, so I'm going to keep on going to my second derivative. If I do my second derivative, it looks like I've got 12x squared plus 6x. Well, do whatever you'd like to do to set that equal to 0. Plus 6x minus 6. Well, I'm going to divide everything through by 6 first. So I've got 2x squared plus x minus 1. Now I'm going to review that cheesy little factoring shortcut that we showed you a while back. 2 times negative 1 is negative 2. Two numbers that multiply to be negative 2 that you can make add up to be 1 is positive 2 and negative 1. And then I'm going to write this as 2x plus 2 and 2x minus 1. And I need to divide one of them by the 2. So that one. So here's my second derivative factored. X plus 1 and 2x minus 1 set equal to 0. Now remember, we're working with our second derivative, so I get possible inflection points of negative 1 and also 1/2. We'll play the number line game with those. So I'm going to plug that back into right there. And if I do that, I get positive, negative, positive in this case. So it looks like my intervals of concavity, I'm going to say that we're concave up from negative infinity to negative 1, along with 1/2 to infinity, and we're going to be concave down on the other. Negative 1 to 1/2. So guys, there's the intervals of concavity. I'm going to skip my number 4. And the reason I'm going to skip number 4, it's just another intervals of concavity. So we would find our second derivative, set it equal to 0, and play the number line game again. But I would like to do number 5 so I can remind you of a couple of things. Number 5 says find any intervals where the function's increasing or decreasing. Now, since I'm back to increasing or decreasing, guys, that means I'm back to my first derivative. So let's think of f of x as x squared minus 1 to the 1/3 power. Well, let's go f prime of x is 1/3 x squared minus 1 to the negative 2/3 times 2x. So here's my first derivative. Looks like I've got 2x over 3 times x squared minus 1 to the 2/3. Now, let's talk about critical numbers. I'm going to have a critical number for sure at 0 because that's where my numerator is equal to 0. I'm going to have 2 more critical numbers at positive and negative 1 because that's where my denominator is equal to 0 at. Now, before I start my number line game, there's my 1, there's my 0, there's my negative 1. I'm not going to work very hard. Something I know about my denominator, whatever number I put in here, I'm going to take the cube root of it, but then I'm going to turn around and square it. So one thing that I know, my denominator is always positive. So I'm not even going to worry about it. So now when I start my number line game, if I pick on negative 2, that's negative. Negative 1/2 is negative. Positive, positive. So there's a couple of different ways we could list this. I'm going to go ahead and say that it's decreasing from negative infinity to negative 1. And then again from negative 1 to 0. And increasing from 0 to 1. And then again from 1 to infinity. Graphically, guys, anytime something like that happens, negative to negative, positive, positive, the graph does something weird. In this case, what this graph does is something like this. Notice that it's decreasing, but at negative 1, it kind of switches and decreases quite a bit more. Levels off, increases, and then decreases. So that's kind of what the graph is. You didn't have to know that, but that's what happens when those show up. Okay. I will do your number 6 with you, because it's got some algebra that I want to remind you about. Find any intervals where the function is increasing or decreasing. So once again, let's find our first derivative, which is going to be 3, and then let's think about 16x to the negative third. Bring down that negative 3 and get negative 48x to the negative fourth. So I got 3 minus 48 over x to the fourth. So there's my derivative. Now, one obvious critical number is going to be at x equals 0. That's the obvious one for right there. Now, to get the other one, I'm going to set this equal to 0. I'm going to move either the negative 3 or the 48 over x to the fourth to the other side so that I could cross multiply. So I'm going to move the 48 over x to the fourth, that way I'm dealing with positives, equal 3 over 1. If I cross multiply, I've got 3x to the fourth equal 48. Divide both sides by 3 and get x to the fourth is 16. And since this is an even number, when I take the fourth root of both sides, I need positive or negative. And the fourth root of 16 is 2. So my critical numbers, 2, 0, and negative 2. Now, when we play our number line game, I'm going to pick on a 3, because 3 to the fourth is 81. So I would have 3 minus 48 over 81. Well, that number is definitely going to be positive. If I pick on a 1, I'm going to get 3 minus 48, which is definitely negative. If I pick on a negative 1, I'm going to get 3 minus 48 again, and then a positive. So when I list my intervals, I can say that I'm increasing from negative infinity to negative 2, and I have no idea why the pen does that, along with 2 to infinity, and that I'm decreasing from negative 2 to 0, and 0 to 2. You cannot say that you're decreasing from negative 2 to 2, because if you look up at your original, 0 is an asymptote. So you can't do that. Okay. Now, in terms of the video here, guys, I'm going to skip number 7, but I'm going to do number 8 with you. That way I do at least one graphing with you, and I don't have a 50-minute video. So I'm going to skip number 7, because I'd like to do number 8 with you. Now, before I start with number 8, I did this little things that I know. Now we're going to find increase and decreasing, relative max, relative mins if there are any, intervals of concavity, inflection points if there's any. But some things that I know before I even start. I have a vertical asymptote at x equal 1, because that's where my denominator is equal to 0. And I have a horizontal asymptote at y equal -2 because I got 2 over -1. So before I even start, I have a couple of asymptotes that I could use. Now, while I'm here, I'm going to go ahead and draw those in. So I got a vertical asymptote at x equal 1. And I got a horizontal at y equal -2. Now let's start the calculus portion of it. I need to find this derivative, so here goes my part A. I'm going to go ahead and use the quotient rule on it. So I've got the derivative of the top times the bottom minus the top times the bottom, which is -1. So I'm going to change this negative to a positive. All over the bottom squared. If I simplify this, I've got 2 minus 2x plus 2x. So it looks like my first derivative is 2 over 1 minus x quantity squared. Looks like my only critical number is at 1. Now I'm not going to work hard. Any quantity squared is always positive. 2 is always positive. So I know this thing is always increasing. So for my part A, where it says intervals of increasing or decreasing, I know that I'm increasing from -infinity to 1, along with 1 to infinity. I can't say -infinity to infinity because of the vertical asymptote. Since there's no sign change here, there's no relative max or mins. So there's no extrema. Now we move on to the second derivative. Well, my first derivative I'm going to think of as 2 times 1 minus x to the -2nd. I went ahead and brought that up so that I could use the chain rule. So my second derivative looks like it's going to be -4, 1 minus x to the -3rd times -1, the derivative of whatever's inside the parentheses. So my second derivative becomes +4 over 1 minus x cubed. So my only possible inflection point is at 1. If I plug in a 2, I got 1 minus 2, which is -1. -1 cubed is negative. 4 over a negative is negative. And if I plug in a 0, I've got a positive. So for my part C, I know that I'm concave up from -infinity to 1 and concave down from 1 to infinity. Now guys, to graph this, I know that I'm increasing all the time, but notice I have nothing else. I don't have any extrema. So I'm going to plot a couple of points. For instance, I'm going to sub in 0 back to the original, because working with 0 is easy. 0 over 1 is 0, so now I know it crosses right at the origin. Now think about this. It's increasing. It's got to approach my asymptotes and go through that point. So here's what this looks like. Now, I don't know if I'm in this quadrant or this. I don't know. So I'm going to pick another point. So I'm going to pick 2. if I pick on 2, I got 2 times 2 is 4, over 1 minus 2 is negative 1. So I know another point is 2, negative 4. Now, we need to graph that, of course. So I got to be increasing and go through this point and approach the asymptotes. So there's the graph. There's the graph of that one. Okay. So there's everything we've done in the chapter right there, guys. Now, here's going to be my last one for you. This will be brand new to you. The concept we've talked about, doing a problem like this, we haven't done. So, we're going to go through this criteria. That should be a D. We're going to go through this criteria and see if we can get a good graph. I'll do number 9. I won't do number 10. That'll make my video right about 30 minutes. That's about the max I wanted. You can try number 10, and I can sure look at it. So here goes part A. Continuous and differentiable everywhere except at -1 and 1 where we have vertical asymptotes. Well, I can take care of that. Let's go draw asymptotes at -1 and 1. Now on part B it says f prime of x is less than 0. Well, what's that mean? That means this graph is always decreasing. I'll try to take care of that here in a minute. It says we've got x-intercepts at 0 and 4. I can take care of that. I've got an x-intercept at 0, x-intercept at 4. So I've taken care of part C. Now, I'm going to write D and E together so that you can kind of see where we're going. It says f double prime is less than 0. So that means it's concave down. So I'm going to put this in order for you. I'm going to be concave down from -infinity to -1. And then I'm going to be concave up. So I'm going to hold water from -1 to 0. Then I'm going to be back down to concave down from 0 to 1. And then back to concave up from 1 to infinity. So I just put it in order for us. Now, there are multiple answers for this problem. So here goes. I need to draw a branch over here that's always decreasing and is concave down. Decreasing and concave down. One possibility would be something like that. That's one possibility. Another possibility, something like that. As long as I'm decreasing and dumping water. So anything like that. So I've taken care of that. Now, let's go between the asymptotes now. I got to be decreasing, but I want to hold water from -1 to 0, and then I want to turn around and dump water from 0 to 1. So to do that, I need to do something like this inside there. That way I'm holding water, and then I'm dumping water. So inside here, it's going to look like this. Kind of hard to see in there, so that's why I drew this on the outside, so you can kind of see where I'm going. So it was decreasing, and I held water and then dumped water. Now I need to be decreasing, but I need to hold water and go through this point. I need to be decreasing, hold water, and go through that point. One possibility would be right there. Like I said, that's one possibility. There's others. So guys, I will leave number 10 for you. That reviews everything that we've done in Chapter 5. Good luck on your review sheet. We got a test coming up, so make sure you're ready for that.